Just a couple of quick examples of vectors that include midpoints. Okay, so in this first question, we've got a parallelogram. Okay, so just think about our shape properties about a parallelogram. We know that the opposite sides are equal in length and parallel to each other. So therefore, if O to A is the vector A, then B to C will also be the vector A. Okay, we might need to use that. And OB and AC are also equal in length and parallel. So if O to B is the vector B, then A to C will also be the vector B. We've got that M is the midpoint of AC. So if A to M would be half of the total length, and M to C would be half the total length. And you might just want to note those on. Okay. You could write, in fact, that it's half B and half B if you want to. You don't necessarily have to. Okay, so first question, we want to go from O to M. So again, we're going to use roots that we need to know. We actually want the vector of O to M, but we have to do it down roots that we know. Okay, so let's do our journey for O to M. We will go from O to A and then A to M. Okay, so O to A is nice and easy. It's in A. We know that's the vector A. And A to M is going to be a half of what A to C is. Okay, now we said that in a parallelogram, the opposite sides are equal. So the vector of that whole length is B. So half of that then is going to be a half of B. So we're going to get an A plus half B. Okay, and that's our vector of O to M. Okay, then B to M. Again, we're going to choose a root. We've got a couple of options. We could go B to O, O to A, and then A to M, as we've just done O to M. Or we could go B to C and C to M. Okay, now we know that B to C is also A, so let's do that. Let's go B to C and then C to M. Okay, well, B to C is A again. Okay, these two are parallel, so they got the same vector, parallel and the same length. Okay, then C to M. Now that's going to be a half of what C to A would be, which is the same length as B, but in the opposite direction. Okay, so C to A would be minus B, so therefore C to M is going to be minus a half B. So we're going to get A minus a half B, and that is our vector of B to M. Okay, so let's do one more example. So in this one, we've got a triangle. Okay, or in fact two triangles because we've got a split there. So we've been told that the vector of O to A is A, O to B is B, and M is the midpoint of this line AB. And we want to find the vector of O to M, and they've actually drawn the line in this time. Okay, so we want to find that the vector of that line. Okay, but again, we can only go down routes that we know. So let's think of a journey that we could do. We could do O to A and then A to M, or you might want to do O to B and B to M. Okay, both would get you from O to M. Let's design a route then. We're going to go O to A and then A to M. Okay, O to A, that's nice and easy. That's A. We know that vector. Okay, now A to M is going to be a half of what A to B would be. Okay, because M is the midpoint of that line. Now A to B, if we wanted to go from A to B, we would have to go from A to O and then O to B. Okay, so let's just do that as a separate thing over here. A to B is A to O plus O to B. Okay, because these are the only two lines we know the vectors of, so we've got to come this way just to get from A to B. Now A to O is minus A, because you're going the opposite direction of the arrow, and then O to B is plus B. Okay, so that's A to B. Okay, and you might want to do that just at the side of your work. Okay, so you don't get confused, or do that before. Okay, so then if we want a half of A to B, so we want a half of that. A half of minus A plus B. Okay, expand the bracket, because although I haven't written it in this example, it will often say give it in its simplest form. Okay, so we've got a half times minus A is minus a half A, and then a half times B is a half B. Okay, and then so simplify that. A minus a half A is a half A plus a half B. Okay, hopefully that was useful. Let me know if you have any problems.